Hello, guys, and welcome back to my element of programming series. This time around, we are going to be looking at the optimized version of what we started in the last episode, where we spoke about the brute force implementation and how we are missing the O of n for the getMax implementation. Now, in this implementation, we are going to be using something very interesting, and we are going to be using double, or will I say two, lists for this implementation to get all operations at O of 1, right? So you see this optimization is this is the optimized implementation, O of 1 at all. I think this is all sorry, at all functions. Yep. So now we call the optimize. So we have two values. Now follow me through this one. So yes, here we are, and we are trying to transverse through the loop and see how what we changed and what makes this a better approach using two values. So if we point into this guy now, we create a self. That's a what's it called, a class, and then we iterate over it. Now after that, we are out, we've instantiated it. Now we go to the next value. Now when we do max.append, we will see immediately here that we create a stack. The max stack and the distance stack basically is created, and then basically our stack that we created before, that's the max stack optimized, now begins to transverse. Now um, let's see how we append. So we see 6 is here, which is the first value, and when 6 is called, it's held in the append value that we try to append to self. And now if self is not self.max stack, right? Basically, if there's no value in it, we should just append it. Else, we should, you know, we should say current self.max stack. We check the -1, we check the value of it, and then the value of the last value, and then we say self.max stack dot append, right? Current. So after appending to this stack, so basically what we are saying is, after appending to the main stack, we should check the last value in the max stack and compare. Oh, is this value greater, or the one coming in, is it greater or so is lesser than the one at the tip of it? And if it is uh so if the value coming in is greater, we accept it, we append it. Anyone that is greater, we just append the max. So it depends. So we are going to see how that transverses. So that's for the first one. So if we go to 2, the same thing. So we could see here where 2 is acknowledged, is brought into this list. So 2 remains, the value is not empty. So we go to the else statement, where we compare the current and the max between 6 and 2. Which one is greater? So we see that 6 is still the biggest. So that's what we append to the max list. So we will see here that we'll just continue iteratively. Now if we look at our max list, we will see something. Our stack is 6 and 2, but our max list is 6 and 6, and that's the magic right there. So after going through everything, we could still be peeping at this. We could see now this our normal stack is 6, 2 and 4, but our stack means max stack remains the biggest big. And then all of a sudden 10 comes into the block, and if we look at our stuff now, 10 is now the biggest guy on the block, and it's also the tip of our stuff. So that's it. When we do get max, it goes into it. Now get max says, now the bone of contention, we do make this O of 1. How do we make this O of 1? Handle if there has been no appending. So basically, if there's nothing on the list and you're trying to get the max, it tells you, oh, there's an error here, and then it just returns self.max dot at the last index, basically like a mark pop, but we're just trying to look at it and see what it is. So rather than pop, we check the last index, right? And that's basically it. If we check our, I don't know if this returns my max stack for me. Yeesh. change. I don't think it does. But yeah, we're going to see that subsequently when we are done. So we could just come here, run our values, and we'll see 10 over here, and also our peak also shows us 10 as well. So 10 and 10 is 10 is showing us the max value, and 10 is also telling us that the edge of our, or the tip of our stack, is also 10. So basically that's the workaround. We can now see that with these complexities that we wrote down in O of, in the what's it called, in the brute force, we can easily just come here and have the same stuff, just change the max to 1, and we are golden. And that's exactly what we've met all the conditions for the question. Muchas gracias. Auf Wiedersehen. Tschüss. See you on the next one.